Hi. In this video, we'll demonstrate the steps for running at risk to simulate a project plan in Microsoft Project. So first, let me look at quickly at the project plan. So here's the project plan with the 8 activities shown arranged here. It does not follow the best practice of having only one start node. But for the purpose of simulation, we are okay with an arrangement like this. So I'll go back to our desktop here. We'll go ahead and start at risk, which sits in Palisades decision tools suite. And so we'll go ahead and double click on at risk here. And so at risk is an add-on to Excel, and hence you see it launches Excel first, followed by at risk itself gets added on. And so these tabs, these buttons also lead to other resources here for learning at risk. But for now, we'll just go straight to running at risk to import. So this is the at-risk ribbon with different capabilities here that we'll use as we go through for importing the Microsoft project plan. We'll go to schedule, import schedule file, and you can then go find it. And so either you should have uploaded your file to the desktop, or you should have, like I have my Google Drive connected to the desktop. And so from there, I'm going to pick up the project plan that we were just looking at and open the file and say, okay. And so it runs an audit to see if the file looks okay. And as I was commenting earlier, it finds these 2 activities that do not have a predecessor. So out of 3, it picks up only 2. So it says 1 is okay to have no predecessor, but you have 3 activities, which is 2 more activities which have no predecessors. And for now, we'll just stay with that. That does not really stop the simulation from running. So we'll say okay. And then it gives us options for defining the model. And that means really for defining, in this particular screen, for defining uncertainty inputs, and for which we have 4 different options. So we will be using the explicit time estimation option. We say show parameters. Now distribution, if you're using only the same distribution for every activity, we could select from here, or even actually we can select the activity or the distribution that's used by more activities than others. So let's just use normal because we'll be using normal for multiple activities and say okay. And that's for just for this example, because for the data that we are going to use has a normal for 4 out of 8 activities. So here is what the screen looks like after at risk has imported it in. Just shows a list view with each activity. The dates here are from a past file, but really we are focused on duration, so we are okay. So just a quick look at what we are trying to do here is these are the distributions that we are going to define for the activities. This is based on the uncertainty information that we have in this example. So the first activity is a normal distribution with the parameters of 3 and 1, 3 of mean and 1 standard deviation. So we'll go ahead and put that in here. And how do you know to put it in here? If you hover your mouse here, it says in parameters. In column 2 is mu or mean. In column 4 is sigma or standard deviation. Second one is beta with parameters 1 to 9. And so we go in here, click on the distribution and change that to PERT. So in what we are doing is in this example, the beta representation by optimistic, most likely, and pessimistic is a representation that is used for PERT analysis. And that's why this program calls it PERT. So we go ahead and put those parameters 1, 2, and 9. And then the next one down is a normal again with 5 and 1. So we just go back, put 1 in here. Uniform 4 and 12. So next one is, so we go ahead and put uniform up here, uniform 4 and 12. Then we have triangular with 4, 6, 12. So the next one will be triangular up here, triangular 4, 6, 12. Next one, triangular 1, 6, 15. Back up. 6 and 15. Next one is normal 2 and 0.33, standard deviation of 0.33. And finally, the last one is the beta with 6, 8, 10. Beta again, we'll use PERT for beta 6, 8, and 10, I believe. Let's just check 6, 8, 10. So now we have input all the variabilities or uncertainty information for each activity. Now we are ready to simulate. And by the way, we can also look at individual distributions by selecting an activity duration and going and on the distribution button here, say define. And that shows us the distribution and shows where we are getting the mean and sigma from the K4 and M4, which we had looked at here, K4 and M4, the cells. That's, or you can look at the actual values here, mean of 3 and standard deviation of 1. It gives you all the other numbers that, given those two parameters, what the distribution looks like. That 1% of the data would be, or less than 1% and less would be, would give us a duration of 0.6737. Similarly, 2.5% of the data would be below 1.04, and so on. So you can look at these details via this distribution button. But back to simulating, we can set here how many iterations we want to set. We'll just leave it at 1000 and just click on simulate. And I realized I left the button on an activity, or left the my cursor on a cell for an activity. No problem. We can, once it's completed, we can go and select on the duration of the project. Oh, I also forgot to select, identify an output cell. So let's close this. I'll move the cursor to 27, and I have to define that that's my output cell, which I missed doing that. I said, okay. And write down the simulation again. And so now it's giving me the output of the simulation, showing how many times in the 1000 runs we had these different distributions. So for example, if you look at 25 here, it's about but let's say it was 0.55 or 0.055. So that would say about 55 runs out of 1000 runs that were done, I had a duration of about 25 days. And here it's telling us based on 31,000 runs, we have the mean turned out to be 29.698, almost 30 days. So the project on an average will take 30 days. Minimum possible, in this case, after 1000 runs, minimum run duration was 20 days and maximum run duration was 40 days. And then you can scroll down to see the different percentile values. So if you're looking at a 90% confidence value, you would quote for this project based on these uncertainty characteristics that the project will take, you would want to quote 35 days with 90% confidence. So that's running a simulation in here and looking at the results. We can also look at, well, I guess let me go back to that. So if you once close the window, you want to go back to that, you can click here on the Browse Results button. And if you want to look at tornado charts, we can click on the tornado button here. And there's several different kind of tornado charts. You have to, for example, we can look at contribution to variance. And this shows the variability of activity F is providing the largest contribution to the output to the duration of the project. So the largest impact of variability in the duration of the project is coming from the variability in activity F, and so on. I'll close that and quickly let's look at the probabilistic Gantt chart. So the standard Gantt chart will show pretty much a similar picture as in Microsoft Project. So there's that picture using basically the deterministic durations as defined, 3 days, 2 days, and so on. We close that. But the other one, which is the probabilistic Gantt, shows the picture with variability. And so each bar here showing how long the activity can take. And then the red point here in the middle, these red points are showing the 95 percentile data. Keep changing these conversions. So, but anyway, so in this bar, for example, the red, no, it's not 95 percentile. The red here is showing the mean values, the mean durations, sorry, the start and ending point of the mean durations. But over here in the smaller, thinner line, the red part is, this is 5 percentile, below 5 percentile, and over here is the 95 percentile. So the black line is showing 5% and 95% points, and the red parts are showing the extreme values outside of that. And in here, you can also see the critical index, which is basically showing how many times a particular activity was on the critical path. And so there's the critical path does switch. In this case, 98% of the time it has activity 3 and 5 on there, but there is 1% of the time when, or 2% of the time when activity 4 or activity D became the critical became on the critical path. So the critical path switches 2% of the time, though 98% of the time it stays with what's shown here. Okay, that was a quick look on going through the steps of running at risk. This is version 8 for running Monte Carlo simulations of a project plan. I'll stop here.